Welcome to the first ever podcast for our series on physical AI hosted by Tryfecta Capital. I have my co-founder here, Nathan Maroney. And Nathan, I think we're going to have a very interesting discussion about why we started Tryfecta Capital and where we're going.
Yeah, Tito, I'm glad you have given me the opportunity to have a chat candidly about where we think technology is going to be applied and the advantages that gives us in the market. I don't know of anyone else in this space kind of thinking around this awareness of operational advantages, trying to join the whole software space with the operational technology space. And probably I'll chat a little bit about my experience doing this with certain companies in my past. So certainly I've seen some ability to harness some of that intellectual property that we've been exposed to.
I mean, that's a great segue, right? I think we need to talk about you're a long way from home. I think you started your life in mining, and now we're
Yeah.
basically talking about AI back into mining. Give us a snapshot into that journey. How did that start? What made you think about Trifecta Capital, and what made you, take this leap of faith?
It is a bit of a leap of faith, but we've done it before. Having said that, I have worked with Tito before, and we inherently share a bit of a story previously having worked together in oil and gas. And on that project, we were technologically orientated, I suppose. That's probably where the big play was around deploying technology to really de-man operations and, use technology to optimize the oil and gas kind of drilling process. And we came from an upstream environment. So knowing the technical disciplines where I started in mining, where I was a surveyor and doing exploration projects, to being exposed to a lot of the automation technology capabilities, and then having to then segue that into software where we had to come up with algorithms that demonstrated our capabilities. And, you were a big factor in me getting exposed to that and understanding how that works in the whole automation space and where we can make market disrupting technology plays. And that was fully funded by a big corporation. Everyone would know who they are. But I think where the evolution of my career took me is I was always focused on technology applications, and there was always R&D applications we had as part of those companies I worked for. So I got exposed to a lot of R&D. I got exposed to a lot of new technologies and how they can optimize and enhance the ability to do an operation, whether it be exploration, whether it be operations, whether it be downstream. Because my experience took me from mining, then over to oil and gas, and then back to mining, kind of a little bit segue back into oil and gas, and then again focused on this pillar with Trifecta around mining. When Tito brought to my attention the capabilities of physical AI, it joined a lot of dots for me in the industry. It took me a little bit to get my head around it, but I could see the future of it because, agentic AI is all the buzz now, but that's going to, yeah, that's going to be developed to a point where it's going to be quite capable, but it's really taking that. And then that's an operational technology that can further enhance, third party technologies such as robotics, and then obviously become a complete solution. So you're joining almost robotics with the AI, and creating a platform for that to move forward. I think I tell you about Astro Boy and how Astro Boy was, he's the perfect example, and then we grew up with that. I loved Astro Boy, and my aha moment is like, hey, we're trying to create Astro Boy, or recreate him in the physical world. So that concept is out there, and our generation grew up with it.
You're not far off because you talk about Isaac Asimov, or any of those sort of legendary people from that era, and they've come up with some amazing ideas. Like, you just take Star Trek and the whole video calling solution, and that was the inspiration for Skype. So a lot of these things that were science fiction back when we were growing up is now becoming reality, and we're really at the forefront of it. We're building the future. So Astro Boy might not be far off from where we reach as a society.
Yeah, would be an amazing concept. And I think Elon Musk and others like him are out there already thinking about this, but they're not quite deploying in the area of filling that gap between the software OT and the hardware OT. And I think that's something where some companies are strategizing around now, but it's how you deploy that and even use that software, a bit like an iOS or operating software. How do you deploy that into the physical structure or an asset, such as a robotics controller? And that's the problem we seek to solve, and where there is a infinite gap. And it takes geospatial awareness, and it takes a lot of things into account that really haven't been hammered out yet. But it's a natural evolutionary step. Think about how these robots will do your dishes for you, will go and peg your clothes out and save you time. They're not necessarily going to, they're going to make your wife really happy. Put it that way. Every husband will have to buy one.
It's one of those things where back in I think the early 20th century, when there were people asking about washing machines and what's the commercial model for a washing machine, right? So, I think that things are changing. You know, I have a slightly different take on it because I've been at the forefront of this for almost the last 15 years. And one of the examples that I keep giving, and I think most of the people who know me would probably be close in their ears because I've heard it that many times, is this example of how the Mongols actually deploy technology. And so we are at this incredible phase in our society where we've actually cracked a lot of pieces pertaining to AI, because AI is not new, right? The whole concept of AI started really in the 70s when they reckoned that biomimicry, and that's what AI is, right? AI is fundamentally biomimicry. It's basically computers mimicking how humans think, the whole cognition. So, when I was in uni, when I was doing AI, we were literally learning how babies think, how babies understand things. When you're giving a baby a block, the babies are looking at the blocks and saying, hey, how do I build something with it? You're building their cognition skills, and you're taking that same pattern and trying to teach computers how to mimic that. And biomimicry is not new. We learned to fly because we looked at the birds and said, hey, if they can fly, why can't we fly? If they're heavier than air, then why can we not fly, right? And you look at, so for the A380, for example, or the B-2 bomber, and they are basically mathematical models of falcons and eagles and specialized birds. And what all we've done is we've tried to picked up how they do things, and we've mimicked with steel how they do it, right? So, without sort of digressing, when we take this biomimicry, it's not the first time. And it's not so much about the technology. It's about how we apply technology that's going to change society and create value. And for us, really about how we deploy capital and how we make money, really, at the end of the day, with the world changing around us, right? How is the economy created? So before we get into a lot of the technical details of it, I mean, coming back to the anecdote that I wanted to discuss, and like I said, excuse me for people who know me, it's one of my famous stories because I love it. The Mongols under Genghis Khan, they had the largest empire on earth, and one of the things, and it's so interesting because what they figured out they could do was they could take cow sinew and bones and other bits and pieces and create this fabulous bow, which probably they may not be the first ones to discover it, but they were the first ones to really popularize it. But this is not where the story becomes interesting, because anybody could copy that. But what they learned to do with that tech was basically the first composites, right? What they learned to do with that piece of tech, or the first composites, if you want to call it that way, was they learned to ride and shoot at the same time. That made them unstoppable. And they built an empire which is still one of the largest empires ever built. And it's all stems, well, the multiple things, but one of the core enablers for that was just the fact that they didn't need to dismount while they could fight while they rode. So the first blitzkrieg, if you want to call it, and they overran people, right? So we come back to this, yes, AI is cool, but we kind of need, how are you deploying tech? So we've already seen this. So a lot of what you're talking about is like the third industrial revolution. We've had the first industrial revolution, which was just hey, we found a steam engine and we could make cotton and we could make clothes, so everyone could have clothes. And then you come to the second industrial revolution, which was all about mechanization and building factories and, sort of vertically integrated. So say take Henry Ford, for example, right? What he did was he built these factories right next to where he got coal and steel, or slightly far away where they're interconnected by rivers. Sorry, so, and what that enabled was a fully integrated factory where you had the coal, you had the steel, and they could pump out cars on the other end. And then you come to the third industrial revolution, which was the advent of electronics in industry. So you could take this factory concept, this sort of conveyor belt concept, and supercharge it. Now, and that's kind of where we come to this, which really is the fourth industrial revolution. And so we said, hey, is AI the fourth industrial revolution? So, and that's my question to you, right? Like, you've been in this industrial space. You've seen how PLCs and machines and factories interact. So, what's the missing piece here? Why do you think we even need to talk about AI in this world? What's going to change? And more importantly, are we going to make money out of this?
Good question. But any market disruption technology is obviously going to have its advantages. And I suppose from a commercial point of view, it's how you deploy it, how you develop it. But the big gap in the industry, from my experience, is getting that data to a point where something can think through the problem, which is not human. Because we've lived in these digital revolutions, which is pretty much what happened maybe 10, 20 years ago. And it was all about harnessing that data, collecting that data. And then it was about utilizing the data. And you have skill sets and disciplines that where data scientists sit over this. And the data science is still a very manual, overlooking task. And I like to explain to people that AI is not really going to replace your job. It's going to enhance your job. Yeah, there can be some low-level jobs that are easily deployable to, say, phone centers or some sort of marketing where it was a manual task. But you still need to know how to use that calculator. And so efficiencies are driven up vertically. So if your bottom floor isn't using the calculator and doesn't know how to use it, well, then they're not going to be able to be competent in the skills and ability that it's going to be utilizing. So therefore, that structure in the horizontal structure of a company is kind of eliminated or minimized. What I'm trying to say here is that there's a lot of technology and data out there, but it's trying to get something that's physical to deploy it, think through it, have an emotional intelligence about it, and think through the complexities of the situation. That's a lot to ask of a technology, and it will take an evolution and step-by-step basis. But to get to the vision, which is Astro Boy, and where we sit today, there's a lot of steps. But our vision is to grade those steps into a workable program where we can absolutely deploy physical AI assets. And the way that we think through it is that we can work and partner with companies that need those assets to critically optimize their operations. Today, energy is more expensive. And not only that, it's logistically inefficient in ways that what we can see is what we have in Australia at this current time, where we only have less than 30 days of fuel supplies. So it's again, it comes as just in time kind of operations or manufacturing was the epitome of all manufacturing, because you operated your manufacturing plant to have what forecasted products that you needed to meet those requirements by clients. And we saw that fall apart during COVID. We're seeing that fall apart now. So you need to have contingencies plans and other things to actually enhance and optimize your operation so that you do have buffer zones within your operation so you can continue operating and don't have downtime in the sense that you can't manufacture. So this is a big gap. Now, that's just a logistics frame, but what I want to point towards is the fact that you can also optimize your operations. And we also have technology like simulation, digital twins out there today, which can help optimize that. But those digital twins, if they were able to be uploaded into a robotics machine that understood as a control mechanism and a controller for an operating system or a SCADA system that understood where it needed to be real time, because the advanced process control is optimizing it. As a control basis, that controller can now integrate itself with the advanced process control or digital simulation real time, whereas you had an external party, which was a human, looking at the problem and probably having a different solution due to the advanced process control's ability to control the process. Now, you want a complete homogeneous society within your ecosystem of, I suppose, an operation, whatever operation is, mining, oil and gas. Now, to get to that point, you've got to have problem and solutions. You're always encountering problems. So how those solutions are determined should be brought up vertically into an operating structure where you have minimal operating management. So your project structures, and they could be humans, and they could oversee a lot of the decision-making mechanisms that I suppose the robotic controllers, I would call them, or dynamic controllers, are able to infuse into your operation. That not only saves you on capital through headcount, but also allows you to optimize your process at an exceptional rate. So take, for example, one of the biggest problems I come across in mining projects is probably the reason why we can't get any rare earth mining projects up and running in Australia is there's too much risk around the geological change. So there's a lot of geological changes, which changes your process. And if the geomets or the process or the metallurgists don't understand what's coming their way, they can't make adjustments in the process, and too much of the commodity goes out in the tails or the end, and it becomes a waste, and you may have to reprocess that at a later stage with another I suppose processing technology that would enable you to extract that mineralogy that you're looking for. And rare earths is a big test case for this, because that risk is so inevitable that you're going to be left with a lot of lost revenue if you can't pick the right geological processing that you need downstream. So this problem is something that we inherently look to solve through this technology that we're trying to adapt. But that takes a lot of thought process, because there's a lot of moving parts. It's not like you can just get an assay from a lab straight away. So you need these assays straight away. You need something that can do the sensing straight away and give you at least a high degree of accuracy, so that your decision makers that are human can make the right process choices, or blend a product with another product to get the content right, so that the process is going to inherently come up with the concentrate that you need. Fixing these problems allows us to then enhance rare earths to our advantages, because China's the biggest producer there is, and they're looking at cutting off supply. The governments have known about this for many years. The Chinese didn't make it a secret. I knew about it maybe 7-8 years ago when I started working on rare earths. China had a policy, 2025, we're cutting off all components of rare earths that are manufactured out of China. They wanted to sell the complete EV motor. They didn't want to sell components. So therefore, if they're supplying components into Mercedes or BMW in Europe, that meant, they're helping them gain the EV market. China's looking at it going, well, we'll just sell the complete motor. So they either have to sell, they have to buy the complete engine off us as Chinese manufacturers, or they've got to find their own supply for the rare earths, which has happened now. So sending rare earth shares up, I suppose, around the world. Now, we're so late to this game. And
yeah. So really
Yeah.
opportunities for, especially here in Australia, where we have just as much access to rare earths as anyone else. And and that's the thing, rare earths are not rare. It's purely about how do you extract it, how do you operationalize it. I think it's just like the Mongol bow. If anybody can copy that bow. It's about how you train the riders.
Exactly.
That's
Yeah.
So that's key. We sort of almost running out of time here. We just got 8 more minutes left in this podcast. And for the next broadcast, we're actually having Jason over, and Jason's going to be talking about IoT. That was really the first foray into sensor fusion, which is critical for physical AI. And that's going to be an interesting discussion. We want to basically come back and get more into the mining side, discuss a lot more about where we are at mining and how mining is going to be an absolute showstopper for both for AI and for physical AI. The interesting thing that I find is back in Davos. So one of the big miners CEO went out there and he actually said, "This is the first time we've been invited for this event." Nobody wanted to talk to mining before, and now mining is front and center for this new revolution, right? One thing I just want to add is, so we talked about the fourth industrial revolution, and if you come back to the third industrial revolution, there's actually an interesting point there. One of the constraints that we've had in the industrial revolution in trying to scale, right? So industrial revolution is about two things. One, we're trying to scale, and two, we're trying to, and by that scale, we're trying to increase productivity, because we need to increase productivity to keep, it's from an economics perspective, because we need to increase GDP, we need to take people out of poverty, we need to, countries need to keep going. Every country has debt. Obviously, as you grow, the economies grow, the debt becomes irrelevant, society keeps moving forward. So it's kind of, the industrial revolutions are kind of critical to get the modern world where we have, right? And in the third industrial revolution, when we started introducing electronics and computers and all that good stuff into industry and into society, one of the constraints we got was, with trying to get to scale, was reduce the complexity. So say you needed to do scarves, right? So you could build a machine that could print out 1,000 red scarves, or 1,000 red scarves with polka dots. But if you wanted a hand-stitched, beautiful scarf, that was impossible. That was, human would take, say, a week or so. So, and then you need to train that human. There's a sort of inherent cost to training someone who develops that. And so you look at the Rolls-Royce model, where they hand build cars. There's only, it takes years and years to build, to train someone to be an artisanal person, who can do specific jobs, who can sort of build a Rolls Royce. And they are kind of on the edge of society. They're like the premium good stuff. 99% of what people drive, as manufactured with as minimal complexity as possible, right? And so this is kind of where physical AI is going to come in, say, hey, complexity is not a problem anymore. And, we're going to talk about IoT, and I doubt we'll have time to talk about digital twins there, but we've got a long few episodes, so we definitely want to deep dive into a lot of these things. But just before we end, we just want to talk about where AI is going as well. A lot of people are concerned about AI. A lot of people are concerned that it's just going to destroy the world as we know. It's not going to be a force for good. It's going to be a force for evil. What are your thoughts on that? What are your thoughts on that? And what do you think? What do you think we're going to see in this new world of AI? Right?
Yeah, it's a good question, because how long's a piece of string, right? How wild is your imagination? This is it would be impossible to think that we would have something like this in our hands, say ChatGPT, only 50 years ago, to see how fast technology is adapted and changes and evolves. And I could poke some, holes in arguments that people are going to lose all their jobs, but I think the overwhelming feedback I get, and my own personal opinion, is it's a very positive change. But just like the smartphones, you got to learn how to use it. Now, there's going to be, I get really frustrated with technology. For someone that's in technology, probably am the most frustrated with it as well, because it inherently has glitches and issues, and you need coders in the background to keep everything running. So there's always going to be a need for a human element, unless, well, if you want my opinion, it will be self-replicating and self-healing itself. What I mean by that metric is that the coding itself will be done by itself and will be repeatable to the point where it picks up its own errors and can reprogram itself to something better. Now, that could potentially be a godlike syndrome for a computer. And that's where I think Terminator and all those kind of wild movies could potentially be, it could turn on us. But that's a big evolutionary step and a long way away. But at the end of the day, if, I paint a picture, there's the Terminator or there's Astro Boy, right? Astro Boy, there's a couple of bad robots getting around, but they got Astro Boy to go sort them out. You know what I mean? So it will be used to further enhance our capabilities and our life and make it better and easy. And it will be. But you just got to know how to use it, how to interact with it. There's a bit of an upskill for everyone. And no one's going to make you do it, but the people that do it are just going to be more fully aware. But I see in my own life, people are asking me all the time about things that they're just not technologically aware. They're very afraid of it. Because I've been knee deep in it, I just kind of take it in my stride. But I have to pull back and realize not everyone is like me, and they're afraid of things they don't know. A bit like your your early monologue around the Mongols, of course, everyone was afraid of them because they had this new super weapon, right? And so that gets around. But one good thing about the Mongols was they were a totally open economy and ecosystem. So when I mean that, they were also religiously open, a little bit like Constantine's edict in 300 and something, around allowing Christianity to be legal. He didn't outlaw anyone else. He just allowed it to be legal finally. So the Mongols had a very similar policy where they allowed whatever religion you were, Jew, Muslim, Christian back then. I think they even had Zoroastrians as commanders, high ranking commanders. And the Catholic Church dropped the ball, so to speak, because Marco Polo was told to bring back priests and convert the Mongols. They never did. But the thing is, there was advantages to that society. And if you stepped across the line, they really punished you. But
that's always the case, right? It's not just about technology, it's about everything around it. And this is kind of where I also think the more case around physical AI is, because AI is just the first step. And it's, if you leave AI in its current form, it's going to destroy things. It's going to make a lot of mess, if you know what I mean. But where, where my personal opinion is that once we get to physical AI is still a way away. We're not, like, for a chat GPT for physical AI is kind of 2-3 years away. And once we get there, we are actually going to see that increase in the economies that we want to see. We want to see that, and we kind of have to build a whole culture around it. And that's an excellent point on the Mongols. It was just so everyone sort of looks at it and just everyone's very singular. Everyone looks at, these sort of tech is just that thing. Let's just like the Mongols and say, just look at the bow. You have to look at the society. You have to look at their policies. You have to look at their culture. You've got to look at their training. And when you put it all together, you kind of see how a simple bow turns into the world's largest empire and how it's sort of changed and shaped the whole world and the history of the world, right? So we are at that one of those moments where, we are going to see this whole evolution of AI change the way we see the world, right? And we just have to basically make sure that we use it as a force for good and as something that, will impact society. There's definitely a moral argument to this as well, right? And I think on that note, I think we need to end this episode. Tune in for the next episode where we are discussing all things IoT with the wonderful Jason. He's got some wonderful insights into it. And we need to come back. Nathan, we need to have you back. We need to start talking about, start getting a deep dive into mining and what are our current challenges in mining and what we need to do for the future. But thank you so much. And it's going to be a wonderful journey. It's just the start of a long road. We'll see where Tryfecta goes and what we enable, especially on the capital front and where capital outflows are going to be placed. Look forward to it, Nathan.
More than happy to come back. Thanks. Appreciate it.
Take care. Bye-bye.
Take care.